So welcome to the, is it third or fourth lecture on Z transform? Yeah.
Third, sir.
Fourth.
Third.
3.5. Yeah. This is the fourth one on Z transform. Right? Mid के बाद चौथा lecture है ना? So you already have 3 of the videos also recorded, so you should have an idea from there. Right, so in the last lecture, what did we discuss? What were the key points? Geometric series, how it has a bearing on finding the region of convergence, right? Also on finding the Z transform. Because the way the Z transform is written, क्या थी definition Z transform की? XZ was summation xn z minus n, right? Yeah, so it can be minus infinity to infinity or 0 to infinity. Two different definitions, but for our purposes, we'll just disregard that. And along with that, you had to define region of convergence, right? So this should already remind you of a geometric series, special kind. So often it leads to sum of series that look like geometric series, and then you have to use formulas like we did last time, that summation a r n, if you remember that, right, was this sum led to a over 1 minus r with what condition? Right, absolute of r had to be less than 1. So you're right, we did look at geometric series, but in the context of the definition of the Z transform, finding the Z transform, and also finding the region of convergence. Now with that, what else did we discuss last time? Properties, right? So how did we get to the properties? Why did we go to the properties? What was the need? Did we discuss? You're right, we discussed properties, but it was part of something. So we said there were 3 paths to doing something, where we had one path was properties and pairs of transforms, right? The other paths were MATLAB, computational, right? You could solve that. What was it? How to find the Z transform. Finding Z transform. So I mentioned in practice, these are the way you use some sort of a computer software, right, like MATLAB. You can use by definition, and last time we did this for some signals, right? Which signal did we apply the definition of Z transform to get its Z? So do you remember? There was in time domain, and then we found it in frequency domain. What was it? Delta n, right? What did we find? 1, a constant, right? So an impulse in time becomes a DC, right? If you will, a DC or a fixed constant value in Z domain or the frequency domain. What about, what else did we do? U and unit step, right? What was that? Z over Z minus 1. And of course they had region of convergence associated with them. Some books or tables mention them, some skip them. They are, you can find them if you need them. Yeah, but for now, these are the pairs we solved using definition. But as I mentioned last time also, when we looked at the properties, what was it that on when you're doing pen and paper, definition can often be very hard to do, right? So then what you do, you take commonly appearing components like delta, like un, like gamma n times delta n, gamma n times un, all those, you do those by definition, but then you have a table of those which are commonly appearing. So that table is in your book. You should take a look at it. You should be able to identify what's going on in the table, but you don't have to memorize it. I provide it in the exam, but having the table in the exam is not enough if you're going to look at it for the first time in the exam. Believe me, you will in most cases end up using the wrong formula, or if you even find the right pair, you may end up using it incorrectly. You won't know, oh, okay, what's going on here. Yeah, so familiarize yourself, and the opportunity you get for that will be, we will solve some examples today, and you will have your assignment. There will be a quiz on this also, so you'll have several opportunities provided that you avail them. Yes, so that is up to you, of course. Right, so this is from definition, we're forming a pairs table, right, of commonly appearing signals. Yeah, then we discuss the properties. So does anybody remember any of the properties of the Z transform that we discussed? Sorry? Linearity, yes, very important property. Z transform is linear. So some of the properties that we discussed: linearity, I won't write the whole thing again, but it had, what else did we discuss? Convolution. We discussed convolution, shift. What about convolution or shift? Let's write shift first. What happens? All of this is saying if xn has Z transform xz, then what is shift saying? If you shift the original by n minus m, what happens? This thing xz gets multiplied by z minus m. Yes? So you do one thing in one domain, something else happens in the other domain. Okay? Which is often what we want to actually do. So you mentioned convolution, very useful. Actually, the whole story started here. What was that? It was times x to z. Fourth, what else did we do? Multiplication by, yes, a exponential in time. Yes, so if you multiply by an exponential in time, what happened in frequency? Z transform.
Z over that.
Yes, z over gamma. And depending on gamma being greater or less than 1, this could be compression or expansion of the signal in Z domain. Right, so fifth, yes, multiplication by n, nxn. What did that lead to? Something very interesting. It led to a derivative in the Z domain, right? And multiplied by Z also. Then there were some two properties a bit less used, but I'll just write them here. And these are by far not the only ones. Some books have huge tables. Your book has a decent sized table. I have picked a few of them just to discuss with you. You can look at the rest, yeah? And you can see their proofs from definition. They're not too, well, in most cases, they're not too hard. So there is time reversal. If you flip it in time, the Z is replaced by Z inverse. Yes? Okay, so a very quick trick question. What is the Z transform of delta minus n? Quick thinkers. Right, so what is it? No, it's not minus.
Minus Z.
Okay, that's one thing. Any other
minus
see, I can confuse you with this. You have to, I think there's something fundamentally missing in the way you approach functions. आप लोग थोड़ा सा ना वो shooting in the dark में चले जाते हैं, which is okay. for some fields of life. But here you have to have a systematic thinking you need. Yes? Just ask yourself this. Okay, let's start here. You have this here, right? So delta n is 1. We agree? Corresponds to 1. Yeah? The property is saying if you reverse in time, the z variable is replaced by z inverse. Now you reverse in time, you've looked for the z variable, you didn't find it, there was nothing to invert, so delta minus n is also 1. there is no z. Is it here? Right? So basically, delta n minus n is also 1. I'm not sure if I'll have to see if region of convergence would change because of that. That may happen, but otherwise the formulation is same. Okay, so you have to go systematically. Ask yourself, what does xz have? Well, xz in your case was 1. Now you're saying I want to replace it with xz inverse. When you do that, you have to find z everywhere. It shows up, replace it with z inverse. That's how functions work. Right? ये एक चीज आप लोग अभी तक उसका fully grasp नहीं कर रहे. So try to do that because this is analytical skill or the basic mathematical skill that is very critical for all that we do. Okay. Oh, there it is. Finally, we have when you conjugate in time, you get a conjugate, right? Okay. So now again, trick question. What's the transform of this? So first you try to replace z with z conjugate, but z is not there, so it's still 1. Then you take the conjugate of 1, which is a real number, so doesn't really affect anything, so it's back to 1. Yes? Clear? Okay. So let's say what is the, now another, not really a trick question, but what would u minus n be? The z transform of u minus n.
Z minus 1 by z.
Undefined.
Right, so what happens? Un has z over z minus 1. Right? So we are saying if you flip in time, then there is replacement by z inverse. So one of you mentioned you just replace these z's by z inverse, right? So you get u minus n corresponds to z inverse over z inverse minus 1. You could try to multiply and divide by z, right? Just z, so that to simplify it, and what will you get? Multiply and divide by z. You get this becomes 1. This becomes z times z minus 1 is 1 minus z. Right? Agree? So this way you can use the properties and the tables to find some of the functions or solve for some of the functions. Okay. So we have gamma and xn, that is there. That's good. We have what we need to get started. Okay, so today with this, a big part of today's lecture is letting you play around with some of the examples. Okay, so you try to solve them. I've already given you some ideas how to go about doing it. First one, first practice problem. Xn equals 5 plus 5n un. Black में जो है, yeah, in black color. This is xn, and you have to find xz, the z transform of this signal. Okay, xz. So I'll give you about say 4 or 5 minutes to try. So we need to 5 plus 5 and 5 plus 5 raised to n times un. Okay, so find me the z transform of this function. And since these are practice problems, I want you to give it your best shot, yeah, for next 3-4 minutes. Then I will take a look and we can discuss the solution. क्या वन होगा? Z को हम वन करेंगे. Z को आप नहीं छेड़ेंगे इसमें. Z बस रीजन ऑफ कन्वर्जेंस बताने के लिए, Z ट्रांसफॉर्म करने के लिए. सर कुछ तो दिया. 5 plus 5 कर दिया. तो किया. बाकी का क्या कर दिया? क्या किया? पता नहीं सर ये प्रॉपर्टी कोड्स और स्टेप दिखा है. गुड. जो आपने यूनिट स्टेप से स्टार्ट किया उसको. यस सर, इसको अलग कर लिया. और सर इसके ऊपर वो जो था सर r पावर n और xn, इसको 5 plus 5n सर 5r हो जाएगा xn, x z by r, z by y. z by 5 x क्या आएगा? सर 5. यस सर 5. थोड़ा सा भी है डायरेक्शन थोड़ी सी अच्छी स्टार्ट है, लेकिन बस गेटिंग देयर. 5 to be even. अच्छा. First you have to start with one of the properties. Yeah. What is that property? Linearity of Z transform. Yes. You can make your job easier by converting this into two terms. Yes. What will be the first term? 5 plus 5 un. 5. The second term will be 5n, 5 raised to n un. Why do we go in that direction? Because we know Z transform allows us to write terms out and then take Z of each separately and then sum them. That's what linearity says, right? So now try it. Then do the Z transform of each term. Yeah, why are we able to do that? Because of linearity. So I'll write the first step that I mentioned. It's already started, yeah?
Yes, sir.
We start by making use of the fact that Z transform is linear, so we already try to write it separately in terms. Integration में भी तो यही करते हैं ना. If you were to integrate this thing, you would split it into two terms, right? Because integration is also linear. So now what you ask yourself is, okay, what is the Z transform of this and what is the Z transform of this, right? So firstly, what's the Z transform of this term?
Minus 5 Z.
5
Z minus 1.
Right. Because this also included in linearity is homogeneity, so scaling by 5 doesn't do anything else, right? So if un originally was Z by Z minus 1, then 5un is 5 times Z by Z minus 1. Nothing to do there. What about the second term
So
now?
Z by Z minus 1, Z by 5. I guess.
What?
Z by Z minus 1.
So Z by Z minus 1 over. और उसके बाद फिर Z by 5.
Z by 5. Why?
It's what?
Sir,
Sir, fourth property.
am I missing something?
सर x की जगह हमने U and पुश करेंगे.
आपने मुझे भी confuse कर दिया. They have to see my notes
Sir,
now.
U of
Let's
U of जो Z है Z upon 5.
Yeah, closer to what we have to do. Listen, for un, it's Z by Z minus
Yes, sir.
1. We say when you multiply by, this is what's happening. This you have identified, right? Fourth property. Okay. What does it do? Gamma n, which is now 5n. So your gamma is 5. It says whatever you were going to have originally, which is xz, in that replace z by z over gamma everywhere,
5
right?
minus 1.
So now I'm going to first write the original. Un was supposed to have a z transform this thing, right? The original. But now because of the multiplication with the exponential, it's saying replace z wherever it shows up by z over gamma, which is 5. So z by 5, z by 5. इसका simplified लिख सकते हैं आप?
सर वो रिप्लेस
Z
वाली बात
minus
एक बार
5
फिर से
upon
बताएंगे आप.
5.
जी रिप्लेस टू.
So 5. Z upon Z minus 5.
Yes, basically काफी simplified form में आ जाते हैं. Z upon Z minus 5. Right. Yeah, replace value. Okay, let's see. What we're saying is you want to find the Z transform of 5n un. Yeah. You have in your toolbox this tool or knowledge that un has Z transform C over Z minus 1. So un corresponds to this, let's say big U Z, right? This is what it corresponds to originally. un corresponds to big U Z, which was what? Z over Z minus 1. The property says if you multiply such any function with xz with exponential, which you are doing now, so you are making it 5n u n, right? The property says in the frequency domain xz is replaced by xz over gamma. First you identify gamma, it's 5. So it's saying xz will be replaced by xz over 5. Now if I tell you that xz equals z square, let's say, to answer your question of replacing the variable, yeah, or the argument, if xz is z square, what should xz over 5 be? Of course you go and replace z by 5 wherever it shows up in the function. It could be in the region of convergence, it could be, if it's a piecewise function, then in the definition of the pieces. So you will make it what? Z by 5 square, right? Some of you will do it like z square by 5, which will again be wrong. Yeah, z becomes z by 5. Everything else that was happening to z will now happen to z by 5. So if this function had another term, let's say cosine z, then what would you have in x z by 5 plus cosine z by 5, right? So for all what really happens in this kind of transformation or change in the argument is that the argument is replaced by this new value everywhere. That is how functions work, right? So this has nothing to do with Z transform or anything we did in this course. It's basic maths, right? So please have this very clear in your minds. Practice it a couple of times and it gets very easy. I don't see any difficulty in this as long as you really sit down by yourself and practice it to make it clear to yourself. Yeah. So now un was z by z minus 1. 5n un is saying make it z by gamma, which is z by 5. So replace z everywhere by z over 5. Yeah. Again, this xn is not really xn. It's just saying any function in time, right? So now in your case xn is what? un. Yeah, so don't get confused by me using xn formula to un. Yeah, that's it's just a variable or just placeholder, right? So then 5n un becomes z by 5, 0 over 5 minus 1. It doesn't look very elegant, so if we multiply and divide by 5, we can easily show that actually the second term, as your colleague mentioned, is z over z minus 5. So then the z transform of what I asked you to find becomes 5z over z minus 1 plus z over z minus 5. ठीक है? Just multiply and divide by 5 to see that this will happen. Clear or not? कुछ idea हुआ?
Yes, sir.
Yes? Okay. Then you are ready to solve the next one. I don't know if you have seen Johnny English. I don't know if it's the first part or the second that he asked his Zen master, this guy monk, am I ready? And he says, second one? Okay. And he says, no. So hopefully that's not going to happen here. Let's see. Z over z minus 1. Okay. So the second practice problem is this thing. Xn is 5n plus 1 un. Yeah. Find the z transform. Again, since it's a practice session, mostly today, I want you to give it your best shot for next 3 to 5 minutes. Or give it the best shot of the guy sitting next to you. अच्छा क्यों भाई मुश्किल हो गया मामला काफी
The power में जो n plus 1 है.
Yes, this will tell you that there can be many problems which Apparently, you cannot use the given properties, but you can with small algebraic trick.
That's good. और वैसे सेम पावर ले लो तीन
वही क्या है
5 and 5 हो सकता
हाँ
है
5 1
5 and 5
5 1
3 1
और तो इसका क्या करेंगे
सेम है पावर ले लो ना 5 पेंटो सन हो जाएगा 5 n मिल गया मेरे को प्रॉपर्टीज मिल गई 24 सर 5
आंसर है सर 5
आगे
तो z over z minus 5
5 g और 5
सर ये एंड आंसर
हाँ समझ गया
सर z over z
हाँ तो
z
ये
over z minus 5 होगा
g और g
5 हाँ
5 into
क्यों
0 5 माइनस हाँ ये अगर कंप्लीट करेंगे तो वही होता है
क्या लिखवा रहे हैं आप फाइनल आंसर?
सर g over g minus 5 into 5
ये क्या है? है ना?
z
यही क्या है?
yes sir
Yes, it's correct. So
यस सर यही है
good. So you are ready.
सर हमने पावर्स को भी बेस सेम करके
Yes, that's it. Basically, it's a very basic algebraic trick. Even though apparently this formula wouldn't work here, right? But you know something else about linearity, which includes homogeneity. So you can say, okay, it's 5 times 5n times u n, right? And this 5 will have no bearing on the output, so it's the z domain is still a multiplication by 5. What's left, you already did that, z over z minus 5. So yeah, good. इसलिए आप लोग मिलके जब काम करते हैं तो अच्छा होगा. एक we should take a collaborative final.
यस सर एग्री
Agreed? Okay. And then it's because you'll have taken it together, everybody will be on average, so you get the average grade.
यस सर ओके सर फिर मतलब
अच्छा.
Because average is
We'll see. Right. So one more, a bit more involved.
अभी भी कैलकुलेट करेंगे
xn is minus 2 delta n minus 4 plus 3 by 2
ये से देती है
n plus 5 by 3 3n times u n. So I think कोई आंसर डाल, ये याद हो गया आपको u n का z over z minus का?
यस सर
un corresponds to z over
जी
z
माइनस
minus. Okay. G. Take 6 minutes. Try it out.
अच्छा ये मल्टीप्लाई हो जाएगा डिवाइड तो -2 डेल्टा n minus 4 -2 3 over 2
n minus n x into n minus n
Sir, 3 over 2 z of n.
लिखा क्या हुआ? कौन सा?
3
ये this is 2. No, it's not z.
अच्छा
2.
just 5 over 3 3
ये n में है ना, इसमें मैं z तो नहीं डाल.
हाँ प्लस 5 और 3 3 है
minus 2 delta n minus
u1 होगा अच्छा आफ्टर करना फिर ये जो कोफिशिएंट लगे तो कितना हुआ
-2 and -2 plus 4
तो कोफिशिएंट जो है
मल्टीप्लाई में एक ही बात है
So minus 2 plus 3 over 2 is equal to minus 2 plus 5 over 3 is minus 3 over 4. हो गया बराबर है
minus 4
x minus
minus 4
Yes, yes. 4.
minus 4 है तो 0 लिख ले 0 हो जाएगा हो गया 0 मैं 1 नहीं होगा
0 and minus 4
0
2 पर
I think
0 हो जाएगा
क्योंकि
हाँ 0 हो गया सर हो गया
हो गया?
delta 1 delta 0 के अलावा 0 के अलावा
delta n minus
0 के
four
अलावा 0 होता है हाँ ना तो n minus 4 भी
minus
होता है
two
हाँ।
include
वो तो सही है
सीमा 2 2 पावर है ना 3 पावर
and x
थ्री ओवर टू
minus
2 ओवर n
ये ना तो
d x of d
बस ये है पूरा
पहली टर्म गलत है बात।
delta है सर 0 नहीं होनी
तो 0 नहीं होगा
सोचा है।
minus 45 41
ये तो
plus
2 नहीं ये ना ये है 0 और प्लस 5 सर हो गया कुछ साफ करके
खुश हती के नंबर।
सर वापस कुछ
वो तो क्या शायद गलत है
सर कुछ ऐसा ये तो
वो x into
So second, third term seem okay. First one में क्या लिखा?
सर वो स्टेप था 1 आ गया तो उसका अगर -2 n -4 है ना सर
minus 2 नहीं है
हाँ n -4 है n -4 ही है तो उसको सर कोई फर्क नहीं
So you are mixing time and frequency domain. देखें आपके
बाकी दोनों फिर ऐसे
Z ट्रांसफॉर्म में N भी आ रहा है, Z भी आ रहा है। ऐसी होती है एक मिक्स रिप्रेजेंटेशन, मैंने आपको भी सिखाई नहीं है। हाँ लेकिन इस केस में वो ठीक नहीं है। Okay, so I see that most of you got these terms right. Yeah. ये तो straightforward है ना, हमने already this is the example. We have already done that. So this should be 3 by 2 z by z minus 2. Yeah. And this should be 5 by 3 z over z minus 3. That's fine. You guys are a bit confused here.
Sir, 2z power 4 x of z.
Yes, x of z is, you know x of z already for this case, right? Delta n के लिए कर रहे हैं ना, तो original x z क्या था delta n का?
-2
1. तो उसे replace कर दे बस, तो 1 है तो वो खत्म हो जाएगा. But I think you got the closest so far. एक I think आपका signs में भी negative में होने चाहिए.
-2
हाँ, -2. So minus
z
2
power 4
z power
4
plus 4 or minus 4?
plus 4 ना, क्योंकि माइनस माइनस प्लस हो जाएगा. नहीं
अपना नहीं लगाना formula. You have to see what this is saying. It's saying if there is minus m, that goes here.
-4
अगर यहाँ plus m है तो यहाँ that side. Yeah. So this is -4, so that goes there, right? Plus 3 by 2 times z over z minus 2 plus 5 by 3 times z over z minus 3. Okay, now I saw some of you made it 0, but firstly it's not 0. You are saying, okay, at n equal to 0 it's 0, I agree. But this is a general function. We never said n has to be 0. It was shifted delta, and it shifted to n equal to 4. I had to say now, we didn't say that in this formula you only are allowed n equal to 0 value. You could have n equal to 4 and then it's not 0. पहले तो ये. So you don't solve it in time domain unless it's helping you. Like we did that in time domain for this case, remember? Because it was gonna help us. अभी जो आपने किया ना एक तो गलत सही करें तो शायद it will help you, but I think you. But good try. Is it clear now?
Yes,
This
sir.
one?
Yes, sir.
Okay, good. Now we have talked much about the Z transform, right? What is missing, I will just start that a bit and then we will continue with that in the next lecture, inshallah. That is the inverse Z transform. Remember, I mentioned we often have to take the inverse Z transform also. Yeah? Why was that? किसी को याद है from last lecture?
Frequency का time.
Yeah. So often the day we look at data or plot it, we want to be in time domain. Yes, and often the things, the way they go is this: you take xn's z transform. Yeah, you take the z transform of hn. You play with these, whatever you want to do, analyze, process the xz through this, and you have the output simply as xz and hz, right? But then after everything is done, you want to go back to the original, yeah, to the time domain. So then you need the inverse z transform, which is the inverse z transform of yz. So I mentioned the formula of inverse z transform using contour integrals. Yes. So, but in reality, how do we solve the inverse z transform? Okay. Rarely by definition. Okay. Again, 3 branches. Finding. What's this? How do we find z inverse? Again, of course, as you may suspect, one is through a machine, computer, yes, such as a program on a computer, MATLAB, Mathematica, etc. Yeah. Then there is another approach, or let's say the second or more commonly used on pen and paper approach is partial fraction expansion. Yeah, okay. You have done that. Right? Yeah, partial fraction, you expand with that. So you do PFE, then you apply properties and table. And the third approach is long division. Okay, this you will see in the lab. This I will discuss with you. This one I leave it as a reading exercise. You can just look at it in your book just to get an idea. Just remember, this one usually does not lead to closed form solutions. Not available. Okay, usually the solution long division gives are not closed form. Okay, closed form पता है क्या? किसी formula, known formula या उसकी शक्ल में. Yeah. So this is where we will focus mainly. Yes, I will give you one quick idea, one example of how we use this second one to get the inverse Z transform, and then next time we can maybe look at it a bit more if needed. Otherwise you can practice on your own. Let's see. So how do we use finding inverse Z transform? Okay, using partial fraction expansion. Firstly, this is the first step we do. Apply PFE to xz over z. Okay. So your goal now in inverse Z transform is what? You have xz and you want to find xn. Right? This is what you're looking for. So first thing you will do is apply partial fractions to xz over z. Why not apply it to xz? You could do that, it will lead to the same solution, but it has been found with some experience that this leads to more elegant looking solutions. We can see an example of that. So second, once you have done the partial fraction expansion, multiply whatever you got by z. So you got rid of this effect. Like you do in completing the squares, you add a term, you subtract a term, right? And that helps you make a nice square, yeah, in completing the squares. Similarly here, you divide it by z when doing this step. After when it's done, you multiply by z to take away what you added by yourself. And then third, use table to get the, and the most commonly used one in that table is going to be this formula, corresponds to gamma n u n. Okay. By now you should know we had 2n, remember, so whatever you had here showed up here, remember, so we now have a shortcut. Yeah, this is the formula that we are going to be using there. So let's see a very quick example to bring home the point. Let's say I have given you this thing. Firstly, let's make it even much easier. Let's say I tell you that xz is 8z over z minus 4. Okay, and I ask you to find its inverse Z transform. Yeah, so here partial fraction expansion is not needed because it's already just one simple root. So what's the answer? 8 in time, 8 times 4 n, right? This is 4n un. Yeah, that is the answer, no big deal. Yes, so just to make it even more interesting, then what would be the inverse Z transform of this? Without even using any of these, first let's start with this. Shifting wali, yeah?
Yes, sir.
So xn minus m corresponds to z minus m times xz. So what's gonna happen?
Xn minus 3 plus 3.
N,
Yes.
same, na?
Yes,
So
sir.
n minus 3. So n will be replaced by n minus 3 everywhere. So क्या होगा ये 8 4 n minus 3. Replace n with n minus 3 everywhere. So right. So you can of course do with the basic properties, but now let's come into partial fraction expansion, which is more general. What does that do? So let's say I ask you to find the inverse Z transform. Of course, if I ask you to find the inverse Z, then I give you xz, right? Something in the Z domain. Yeah. So I give you 8z minus 19 over z minus 3 times z minus 2. Okay. So those of you who remember partial fractions will know that the way they start, usually what's the goal of partial fractions? is to rewrite this kind of problem as a over z minus something plus b over,
z minus 2.
right? From one big term you go to two terms. Why would that help us in Z transform? Because Z transform is linear. So inverse Z transform is also linear. So we can then separately work with these, yeah? But before that, what is the approach I told you here? Based on our experience is don't do this with xz. Apply partial fraction expansion to xz over z, right? So first you have to bring in this thing. Okay, this thing we have changed it, so we will take away that effect in the next step. But for now we need it, so we will have this z. Yeah. Now, those of you who remember partial fractions, if you don't worry. It's in your in the book in the background chapter. It is there. Just find it. You have done it before. The first thing you always do is identify the nature of the roots, right? Number and nature of the roots. So roots इसमें कितनी है? 3. Are they real roots or complex roots? Real roots, right? z0, z equal 2, z equals 3. Are they repeated roots or distinct roots? Distinct. So in partial fraction, this is the easiest case, right? When the roots are real and they are distinct, that is usually considered the easiest scenario. So firstly we did this, and for our convenience I will be calling this thing fz. Okay, you will see why I need that in a bit. Just revise your partial fractions method. Here I will just summarize that from the Z transform point of view. Okay, inverse Z transform. So what's going on? I want to find the inverse Z of this. It's hard to do. Okay, it's a very involved function. So I use this approach. If you want to use MATLAB, it's fine. But when you want to do it pen and paper, this is how we go normally. So then, what you do is basically that is step 1. Okay, and in step 1 you have to now do partial fraction expansion of this thing. Yeah. So what is the partial fraction expansion of this? Can anybody tell me? Z minus 3 times Z minus 2 times Z. So there are 3 roots, so we expect 3 distinct roots, so we expect 3 terms. Yeah, A over Z minus 3 plus, okay, I'll write what I wrote here. So I started with Z plus B over Z minus 2 plus C over Z minus 3. Right? The order won't matter, these are just variables. Yeah. What do you do next? एक तो वो shortcut होता था cover up rule. अगर वो shortcut सीख लें अच्छा है. Otherwise, of course, as you say, multiply by this thing. So then you say A happens to be, if you want to find A, multiply fz, which is this thing, by its denominator. Yeah. So z times fz, and solve it at the root of the denominator. This one. इसकी root क्या है? 0. So you multiply with this and set it to 0. Why would that help? You can already imagine. From the left maybe you won't see it, but see on the right side. Why is this equal to A? If you multiply out this thing by z, this term becomes A. Right? These terms become A. These terms, what happens to them? You put z equal to 0 here and 0 here, and basically you will get A here. Let's see. Yeah, this will help here. Where is z? Yeah, this thing. You multiply out by z so that this the root that was going to make this infinite disappears, right? So then A is z times f z. Okay, I'll show you one example here for, let's say, C. What would B be, by the way? Let's say, what would C be by this approach? Whatever the denominator of z minus 3 times fz at z equals 3. Yeah, so let's solve that. Let's solve that quickly. over here. I will just write it. Basically we are saying z minus 3 times this whole thing, which is 8z minus 19 over z minus 3 times z minus 2 times z. Yeah, at z equals 3. Now some of you may first put z equal to 3 here and then get a form this 0 over 0. Don't do that, simplify it first, right? Get rid of this and now put z equals
2.
3. We are solving for c. Yeah, if we were solving for b, then this would be z minus 2 and at z equal to. So I'm a bit rushing through this because you know this partial fraction. There is also cover up method which just says, you know, cover up. I think if I remember correctly, you cover up this part. If you're looking for a, you cover up this part and then put z equal to 0. Yeah, if you're looking for c, you cover this part and put z equal to 3 in the rest of it. This is what's happening. Yeah. So there are shortcuts people have devised. Just look at that. It will save you some time. But then what happens? Now you can put z equal to 3 here in all of this.
Answer will be 5.
Right? So क्या answer आ रहा है बस?
5.
5 over 3 आ रहा है बस. 8z है ना? 24 हो जाएगा minus 19 divided by
6.
right? So what I'm getting is c equals 5 by 3. Similarly, you will find a, b, right? Once you have found them, you can put them here. So in my case, I found a to be minus 19 by 6. I found b to be 3 by 2. And as I showed you, c was 5 by 3. What's the next step? So far you have done just this, right? What's the next step?
Put the values of ABC.
Multiply by z. Yeah. So now you multiply this thing out by the whole thing by z. If you do that, notice that you're back to the original without the z. But something interesting happens on the right hand side. What happens? If you multiply by z, you get minus 19 over 6 z, right, over z, which is 1 plus 3 by 2 times z over z minus 2 plus 5 by 3 times z over z minus 3. What's the last step? Now you have divided this problem into 3 terms, right? Apply the table, the z transform table you have. Read it now the other way, right? Before we were reading from here to here, now we read it from here to here because it applies both ways. And then what do you have? Let's start with the easy term. What does this term convert into? What's the inverse z of this? This one.
The 2 power.
2 power n, yes. With what? So of course 3 by 2 remains as it is. It's a multiplier. Z by z minus 2.
2 power.
2 power n times un. हाँ वो आप छोड़ रहे हैं ना असली चीज. Right? Okay. What about this term? 5 by 3 is a multiplier, stays there. 3 times 3 raised to n times un. What's the first term? Quickly.
Sigma.
Yeah, delta. Yeah, sigma out. Good. So minus 19 by 6, if they have got it right, delta. Yeah, you're right. Delta n. So notice what you have found. This is xn. You have gone from this xz to xn. Okay, these are the 3 steps that you had to follow. The partial fraction expansion step will change depending on nature of the roots. What I did just now is what? Distinct real roots. That is the easiest. Then what I will leave to you as a reading exercise, please do that, is if you have, let's say which one is also important to us. This is repeated real roots that we did. Oh yeah, sorry, repeated real roots. Yeah. So we did distinct real roots. Please go through the methods for distinct, repeated real roots. Okay. So that means maybe you have z minus 3 square. Okay.
पार्शियल फ्रैक्शन सर सारे आएंगे क्योंकि उसके अंदर रिपीटेड है क्वाड्रेटिक
मैं
है
वही बताने लगा हूँ. These are the only two I'm interested in.
repeated and non
Repeated real and distinct real. बाकी I'm not interested. Okay, why? Because that's a different subject. हमारा goal भी transform है ना. If you understand it, I don't want you to be bogged down by older methods जो आपने already किए हुए हैं. But please, ये दोनों आपको आने चाहिए. Use whatever shortcut you want to learn, cover up method, or even within the repeated real roots, there are multiple ways of doing the partial fraction. There are shortcuts. People do it one way, some people do. So just read the book, see there if you want to do another one, but you should know that one very well. So with that, I will assume we are done with the inverse Z transform. And the next lecture will actually take us towards an interesting interpretation of the Z transform. Okay, and most likely the last lecture on Z transform. We'll see. Okay, thank you so much. Any questions? No? Okay.